Hi everyone, welcome back to Linux. In today's video, we are going to solve the LeetCode problem number 3558, that is number of ways to assign the edge weight 1. First, let us understand the problem and then we go for an approach and a solution or writing code. They have been given an undirected tree, that is when it comes to a tree, there is no cycle. If it is in a cycle, then it should be in a graph rather than tree. And they have been given a n nodes and labeled from 1 to n and root at the node 1. So they have been given that the root node is always 1. The tree is represented by a 2D integer array. Let's erase this out. The tree is represented by a 2D integer array edges. Rather than giving in a custom class for us, they have been given the 2D integer array. Each array inside that they have a length 2, that is u of I and v of I, and they mention that there is an undirected edge between u of I to v of I. When it comes to an undirected edge, there have been two possibilities. Either we can go for an u of I to v of I or v of I to u of I. Both are possible. But when it comes to in a tree, we only go from root node to parent node to child node only. We can't go like this. We don't have a pointer to parent. So we need to figure that out. Who is parent between them? Either v of I is parent of u of I or u of I is parent of v of I. We can travel that in the way we will first reach the parent. Okay. And initially all the edges have a weight 0. Okay, the initial weights are 0, and then we need to assign the edge weight either 2 or 1. And the total cost between the any two edges u and v is the total weight of all the edges in the path connecting them. So once we assign the weight either 1 or 2, the total cost between the u and v is the sum of the edge weight between them. And we need to select any one node x at the maximum depth. We need to select one node at the maximum depth, and we need to assign the weights in that edges, so the total cost will be odd. Okay, so we need to find out number of ways. We need to find out number of ways to assign the edge weight between the selected node, so the total cost will be odd. For example, if let's take in a graph of depth 3. For example, we selected this node, and from we need to find out the path from here to here. Okay, we can assign 1 or 2 here, right? In each edges we can assign 1 or 2. So we need to, the question they mentioned that we need to assign the edge weight so that total cost will be odd in that path. So if we select this node, the path is this. Okay, here 1 edges and here 1 edges. So we can assign either 0 or 2 years, 1 or 2 year. So if we assign 1 year and 2 year, the total cost will be 3. Other possible assignment, or we can assign 2 year, assign 1 year, the total cost also will be 3. Here there are two possible valid assignment, but when you assign 2 year and 2 year, the total cost will be even. That doesn't satisfy our question. And also if you assign 1 and 1 in both edges, the total cost will be even. So that's also doesn't needed in the questions. So we need the total cost should be in an odd, that is even. Okay, and since the answer may be large, we need to return its model of 10 power 9, and there is a note: ignore all the edges not in the path from 1 to x. So once we selected the maximum depth edge, we need to ignore all this because it's not in a taken a part between the total cost in that path, right? So we just ignore all that. First, let us understand with an example 2, that is 1, 2. This is an example 2, right? For example, let's take in a maximum element as, the depth node as 5. The total number of edges is 2. So the possible assigning weights are 1, 2 and 2, 1. These are the possible assignments, so the total cost will be odd, right? If you assign 1, 1, that is even, and 2, 2 is also even. So this is not a valid one. Okay. So we don't take this. That's why the output will be 2 here. So let's see some constraints and tricks in the questions. First, let's clear this out. What is this? Okay. They have been given a representation of tree in edges like 2D integer array rather than a custom class. So we don't know who is in a parent between these two. If you, without seeing, for example, in the example 2, without seeing the graph, you can't decide who is parent between 3 and 4, right? We don't know who is parent between 3 and 4. Okay. So we need to find out who's parent between them. They given that root node is always 1. Okay. This is a root node. So using this root node, we can travel to each child. So, and each child and so on. If you do travel like this, we will only see its parent before its child, right? So we can solve this problem by traveling from the root node to its child. By this way, we can find out who is parent. Okay. And so traveling like this from root node to its parent, its child, it can't possible by this array because there is a root node is 1 and 2. We can go from 1 to 2 and 1 to 3. In that question, they have been given that what if the input like 1, 2 will be here and 3, 4 will be here and 1, 3 will be here. So we don't know the one have another child in back. So what we can do was we can create an adjacent matrix. Okay. The adjacent matrix are nothing like it will store the who's or the adjacent to itself. For example, the root node 1 as an adjacent of 2, 3 and node 2 as an adjacent of 1 and node 3 as an adjacent of 1, 4, 5 and node 4 as an adjacent of 3 and node 5 as an adjacent of 3. So we know that 1 is in a root node. So what we can do was from root node I can go for this child, its child. So I will visit 2 and 3 and from its child, from its node and I will go visit its child. So 2 doesn't have any child, so it will end here, but 3 has a child 4 and 5. Okay, this is how we are going to travel. So the adjacent matrix will be looks like, let's erase this. There is no node, there is no node represent as 0. So the first 0th element, they have no reference to any other node. At the index 1, there is a 2 child for a node 1. For a node 2, there is no child and it has a link to a parent node 1. Okay, and node 3, it has 1, 4, 5, and node 4, it has 3, and node 5 it's also having a 3. You can understand the adjacent matrix using this graph. Let's erase this. Because there is no root 0, I just leave it as empty. And for 1, there is a tool child that is 2 and 3. That's why it has a 2 and 3. And child 2, it has only 1 node, it's an adjacent, that is 1. So that's why it has a 1. Okay. So what we'll do was we start from the root node and go its child, that is 2 and 3. And again we start from the its node and visit its childs. Okay, so by this way we only visit parent before its child, so we can solve that problem. We can find out the parent rather than before visiting the child. Okay, we solve that. We can visit order, we can visit by an order. So if we visit by an order, then we can find out the maximum depth in the tree. So if we travel like 2, 3, 4, then 5, we can find out maximum depth. What I can do was, let's take this graph. Okay, I just go to a root node. It has a 0 child, so each will return 0, and it has some node, right? So it will return 1. That this 1 represents the number of edges. So I will come again to 3, and 3 to 4, it has 0 child, so it will return 0, and it has a 4, right? So I will increment by 1 and return 1. And again go to 5, it also doesn't have any child, so it will return 0 plus 1, that is 1. So when it comes to this node, we need a maximum depth, right? So I will just take max of left and right. The left is 1 and right is 1. So the maximum will be 1, and it has a node, right? So we just, while returning, we just 1 plus 1 is 2. So at the root node, we get 1, 2. The maximum is 2. Let's erase this. So in this graph, if you see that the maximum depth is 2, that is this path or this path. Okay. Once we find out the maximum depth, that is n, then we can stimulate the process like number of ways to assign, because the number of ways to assign the edge weight, it's only depend on number of edges, not for any tree. That's why we only care about the number of maximum depth in the graph and number of edges. Okay, there is a ways to find out number of ways to assign the edge weight, so the total cost will be odd. They have been given two possibilities. Either we can assign 1 or 2, right? So when it comes to any problems like assignment of 1, assigning the values, and assigning values will be probably less. Like there is only 2 possibilities, right? There is a trick here. That is, once we find out number of edges, okay, once we find out number of edges, there is, let's separate this n into n minus 1 comma 1. So when we plus it, n minus 1 plus 1 will be n, right? I can assign any value to the up to n minus 1 node. Okay, I will assign either 1 or 0 to each node. Any possible values, I don't care about that, this n minus 1. Because after assigning the possible values, the possible cost between n minus 1 will be either odd or even. Okay, because it's in two possibilities, right? There is only when we sum them up to n minus 1, it will be either odd or even. But when it comes to an nth node, if the given total cost from n minus 1 it's odd, I just add 2. I just put the edge weight as 2 here. So the total cost will be odd. But when the total cost is even, I just put 1 here. So the total cost will be odd. Can you see some tricks here, right? That is, we don't care about n minus 1 nodes. We only care about the nth node, because whatever its sum, it will be either will be odd or even, right? When it's come to an odd, the total cost is odd, I just add even, so the total cost will be odd. So in that edge path, like this is an edge path, I can assign either 0 or 1 to here, 1 or 2, or 1 or 2 here, 1 or 2 here. So all the possibilities are valid up to n minus 1. But when it comes to an nth node, nth edges, because of this all possibilities are valid, there is only one possibility here. When it's odd, we must give even here. When it's even, we must give an odd here, right? So when it comes to an nth node, there is one possibilities, but all the n minus 1 nodes have both possibilities. We can assign 1 or 2. So the total possibilities like 2 power n minus 1, because in each edges we have a possibilities of 1 or 2. That's why here 2. And we don't care about n minus 1 nodes, because we can assign anything we want. For example, for this node 1 2 3 4, right? Let's take it. I just care about this 2 node. I don't care about this nth node. I just assign 1 1. When it comes to this node, that is 2, right? So I just put 1 here, odd 1. So this is a valid one, the odd is 3, right? So when it comes again, I can 1 2 here, that is total cost will be 3. So it is an odd, right? I just put plus 2, that is even. So the total cost will be 5, that is odd. So again we can try out different possibilities, that is 1 comma 2 and 1 1 already tried, 2 2. Whatever the value summed them up, it will always comes to either even or in an odd. So up to n minus 1 is either even or odd. So when it's nth node, we just put either odd or even. So hence each node having 2 possibilities, 1 or 0 up to n minus 1. So we can derive the formula like 2 power n minus 1. So the last node will be forced to choose either 1 or 2. So the nth node will be 1. Okay, that's how the problem we can solve it out. So let's code it out. Let's open LeetCode. This is today's problem. I already run that in my another program, another system. So first, they haven't given edges in 2D representation, right? So we just find out, we need to convert this into adjacent matrix. So adjacent matrix equal to it is used to store the adjacent matrix to its node. The n should be n equal to length of edges plus 1, because the edges have an n minus 1, right? Here you can see that the edges have n minus 1 length, but there is an n edges. So we increment here, and because it's one based indexing, I just put plus 1 here. Okay, this will create the adjacent matrix array. So once after this, we can create the adjacent matrix from the edges, that is a comma b in edges, that is adj of a dot append b and adj of b dot append a. This will store the adjacent matrix between a and b. For ath node the adjacent is b, for a bth node the adjacent is a. So it store that. For your reference, I will just print that adj. It will be looks like our node. You can see that std out print like this. For test case 2, this is how we exactly see in the editor. I just clear that out, or I just erased out, so it's fine. Okay, it's fine also. Once we find out the adjacent matrix, we just need to find the depth, right? So I just create the function like depth. So finding the depth, it upsets the node. Once it's find out the node, I just like if length of that node adjacent of that node is 0 means I just return 0. It's pretty annoying. I just move that little, let clear, sort down. So we don't want to travel from 1 to 2 again 2 to 1, right? So we just create in a visited array. Sorry, we want to create in a visited array, so we don't want to travel its parent again. So let's create in a visited array to visited equal to false star n plus 1. Initially it's false, so we can visit its child. Okay. So when it's visit this node, we don't want to visit it later, right? So we can vs of I of node equal to true. So we don't want to visit this, and we need to iterate to child, right? So for child in adj of node, so it just contains the child adjacent to its node. So once we have a child, if visit of child, initially it will be false, right? If it's false, we can go to that. So we just put not here, so it will become true. When it's true, we can just go for that depth of child, and we need to track the maximum depth, right? That is, it will just return maximum depth, that is temp equal to, we initially like declare temp equal to 0 and maximum equal to 0, and we just find that maximum max equal to max of maxi comma temp. Once we find out these things, we just return it that maxi. But for the maxi plus 1, but for the child leaf node, when I come to leaf node, its child is 0. Child is 0, but when we return it like maxi plus 1, it will just return 1. So what we can do was, so if it is in a child, we don't visit that child. If it is in a leaf node, we don't have any child, right? In that case, this if condition will never execute. So for this, we can create a flag here. Flag equal to true So when we visit them here, when we visit here, it not should be in a leaf node. Okay, it is in a non-leaf node. Okay, in that case we can assign flag equal to false. So when we come outside the loop, if flag is true means it is in a leaf node. That means this if condition it's never been executed. So in that case we just return 0. Okay, let's find out whether it will return the maximum depth or not. D equal to depth of 1 because 1 is in a root node. Let's find out whether it's returning maximum depth or not. Runtime error. What is runtime error? Let's find out what is that error. Everything looks good. Yeah, we need to put 00. I think it should return maximum depth now. Again runtime error. That's the mistake here. Let's figure that out. 1 second. VIS is here. Yes, node 0. Okay. As I told, let's figure that out later. As I told, the formula is maximum depth formula is 2 power n minus 1, right? So once we find out the depth, we can just return 2 power n minus 1. Here we just return 2 power d minus 1. But if you see the constraint, the n is 10 power 5. When you're returning 2 power n power 5, it will be integer over limit. So, and also it's over, when it's go for overflow, we just need to return modulus of 10 power 9, right? In Python there is a function power, it also does that work. Power of 2 comma d minus 1 comma it's take the modulus 2, that is 10 power 9 plus 7. We just need to find out the error now. Actually the error is here. We just put double brackets. Pretty annoying. Yeah, the 2 test cases passed and just submit it out. Preparing runtime. Yeah, I just accepted and that's it. Let's see you on the next video.